Namaste and welcome. Did you know some of the most important discoveries of mathematics have Hindu roots? Why are we so ignorant of this fact? Now you might think this sounds like another everything was invented in Bharat talk. Well, our speaker today, the author of this book, The Imperishable Seed, How Hindu Mathematics Changed the World, also would dismiss such claims as just Hindu nationalism or Indian pride. Let's talk to him on why he decided to actually write this book and what this book uncovers. Let's welcome Dr. Bhaskar ji. Namaste and welcome and congratulations on your new book, sir. How are you?
Namaste, Payal ji. Thanks a lot for having me on the show. I would like to first of all start off by showing you a copy of the book.
Yes, please do.
The Imperishable Seed, How Hindu Mathematics Changed the World and Why This History Was Erased.
Yes.
This is published by Garuda Publications. And yeah, I'll be really happy to talk more on this topic in this talk.
Absolutely. Thank you. Lovely to see the title and the actual cover. Beautiful. Just first of all, before we continue with the questions, a little bit about Dr. Bhaskar Kamble ji. He obtained his PhD in theoretical physics from IIT Kanpur in 2010 and thereafter worked as a researcher for several years in Germany and South Korea, specializing in the fields of unconventional superconductivity and quantum phase transitions. Currently, he lives in Berlin, Germany, where he works as a data scientist. Let's just get into it. You know, I mentioned in the introduction that you were a bit of a skeptic in, when this topic was maybe someone conveyed this about the Hindu roots of mathematics initially. How did you go from being a skeptic to writing a book on this topic? What inspired you?
Yeah. So in my school, I was brought up on the conventional narrative of India and the Hindu civilization being basically all about the caste system and superstition, and India being a backward land, and West as the bringer of science and progress. So I carried on with this belief for quite some time, and sometime in 2009, I was doing my PhD in IIT Kanpur. One of my friends who was more aligned or interested in the Indian civilizational aspects, he happened to mention to me once that the Pythagoras theorem was known in India centuries before Pythagoras in the Sulba Sutras, and that time I did not believe him at all. I thought, okay, it is just another one of those Hindu nationalist kind of stories which are floating around. And so I dismissed it at that time. But later on, I came to Germany and I was slightly becoming more interested in these subjects. And I happened to read an article by a Scottish mathematician, John Playfair, written in 1789. And there he spoke about, he was discussing certain astronomical tables from ancient India. And in the calculation of eclipses, he mentions one point, how the Indians were doing it, that they were using the theorem known as the Pythagoras theorem in their calculations, much before Pythagoras. And this for me was a very important turning point because I had dismissed this earlier belief as just right-wing propaganda. And I thought to myself, okay, if this is what I have dismissed as, as false, how many other claims are there which I may have dismissed as false? So I just went on into a spree of searching for information from various references, from journals, from books. And the more I researched, the more information I found, and I was totally shocked that most of the mathematics that we learned in school till high school even comes from India or has Hindu roots. So this was for me a huge turning point, and I thought that this is something really that must be made known to a wider audience, because just this knowledge is absent in the general population. And this made me start working on this topic more and more. And then I wanted to also what also struck me is that most of this information is there in academic sources which are very technical, or they are not accessible to the lay people. I wanted to bring this also into the foreground and also keep the academic rigor intact. That is to say that I wanted to give references to all my claims that I'm saying, proper references, and so on. So it does not sound like some wishy-washy flights of the imagination. So this was my aim in writing the book. And what also struck me was that when I was a student, one of the most difficult subjects, which for many students is the subject of calculus in mathematics, and I was struggling with it for quite some time. I had to put in quite some effort to learn those things. And during this phase, also I got this notion that the West is really the inventor of this really important aspects of mathematics like calculus, Newton, Leibniz, and all the rest of them. And of course, like I was in awe of these scientists, mathematicians like Newton and everyone. Then later on, I just came to realize that through this article by Charles Wish in the 19th century, that actually even these concepts of calculus, infinite series, etc., they were developed in Kerala, at least 3-4 centuries before their discoveries in Europe. But what finally turned my whole concept upside down was when I read the works of C.K. Raju, where he talks about how even this knowledge of calculus was transmitted from India to Europe. And then I thought that something is really wrong with the way mathematics is taught, and I wanted to really bring this point across. And I thought that it will be so inspiring for Indian students when they learn about all these topics that they will lose their awe of the West, and they will look at these subjects more like as if it belongs to them. So, and this will of course instill a huge sense of confidence in them when approaching these subjects. And these were some of the things which made me write the book. And some other aspects of that, I was also struck by the absence of this information in the general perception, in the general population, and at the same time the prevalence of all this narrative of Hinduism and Hindu society being filled with caste discrimination, filled with social evils, filled with superstition. And I really thought that how come this information about the achievements, about the mathematical achievements, is missing, but all these other negative aspects are being portrayed so relentlessly. So for me, the book was also a means of showing the true picture with regard to the portrayals. So these were some of the things which made me write the book. Yeah.
Really inspiring and so beautifully said. I think when you said building the confidence of our people, it's so important because I'm just remembering I have a degree in mathematics from one of the top universities in the UK, and actually I didn't enjoy my course. I kind of regretted doing the degree. And if I think why, I did actually feel very inferior and I wasn't feeling engaged. And I'm now thinking, if I knew the truth of the matter, if I knew that most what we were learning, or the theory side in maths, was had Indian roots, and I learned from that perspective, I think I would have been more engaged, honestly. But that's life. Let's move on to the title. I really love the title, The Imperishable Seed, of the book. And so I'm really curious to know why you actually called the book this.
Yeah. So one of the things I wanted to also show in my book was the close connections between the Hindu philosophical framework and the knowledge system and the mathematical developments. So like this is one of the major aims of the book. So as far as the title is concerned, so it comes from that wish to portray this connection between the two. So the title is taken from one of the verses from the Bhagavad Gita, chapter 9, verse number 18. It's called, I actually don't remember the verse right now by heart, but there's this one phrase, Bijam Avyayam, which means the imperishable seed, in which Shri Krishna, says that, I'm the imperishable seed from which the whole universe comes out, arises. And so there is a really it's like, and then so in this there is exactly this sort of a idea also in mathematics, especially in the field of algebra. So algebra is known as avyakta ganita, and avyakta means the unmanifest, and algebra is the science, the mathematics of the unmanifest, and the word for arithmetic is vyakta ganita. Vyakta means manifest. So it is from the whole unmanifest, the manifest universe arises. So avyaktat vyaktayah, this is another verse from the Bhagavad Gita. So in algebra is it's you use symbols either for finding out unknowns or representing general solutions, general theorems or general results. So for example, if you have a right angle triangle, you have a square plus b square equal to c square, where c is the hypotenuse. So this is like the unmanifest, the avyakta version of the vyakta. The vyakta could be 3 square plus 4 square equal to 5 square in a particular right angle triangle. But this unmanifest, this a square plus b square equal to c square, it contains all the possibilities of right angle triangles that can ever exist, just like the avyakta contains the entire universe. And this is exactly the idea which many Indian Hindu mathematicians have written about, like Narayana Pandita and Bhaskaracharya, for example. One of the verses of Bhaskaracharya when he speaks about algebra is उत्पादकम यत प्रवदन्ति बुद्धेः अधिष्ठितं सत्पुरुषेण सांख्याः व्यक्तस्य कृष्णस्य तदेक बीजम अव्यक्तम ईशम गणितम च वन्दे. So he says here bijam avyaktam. So not bijam avyayam, but bijam avyaktam. So avyakta bija. So this is a verse where he talks about not only that, it's like a double meaning to it. Like I bow down to that supreme person, to that supreme consciousness, which is unmanifest and which is the seed, avyakta bijam, and which is the cause of this whole universe. And likewise, I also bow down to the science of algebra, which is the cause of arithmetic, from which the entire arithmetic arises. So I thought this would be a nice title for illustrating the connections between the Hindu philosophical knowledge framework and the mathematical knowledge. This was the aim
what
of
a
it.
deeply thought through title. How beautiful. That just made me smile. I mean, you explained it so well as well. So that's really fascinating. So, in you mentioned when I asked you what inspired you about the sources slightly, and I think at the end of the day, anyone out there, whether it's someone who is very much into their culture and you've said this, they'll just believe it. But there'll be others who are skeptical listening to this. So for them, the skeptics, I want to know, why should they us believe what you have written in your book is actually legit? What are your sources? Where have they come from?
Yeah, so the references I've used are pretty standard in the literature, in the research literature, but still, I would still give a summary of the references that I've used so that it's clear, what to expect, what kind of work to expect. So, in any historical work like of this sort, they have two kinds of references. One is the so-called primary references, and one is the so-called secondary references.
Okay.
So in the primary references, you have the original works of the historical figures who wrote their texts, like Brahmagupta or Bhaskara, Aryabhatta, and their original texts in Sanskrit or maybe regional languages also. So that would be the primary references. And as regards primary references, there are many manuscripts in India at different places. Very often you find the same work in different geographical locations, maybe in Maharashtra, maybe in Orissa. And then manuscript collectors, they collect them, and then this scholars can then cross check and establish a general chronology of this. So what happened was that when the Europeans came to India, especially the British and the Germans, they were really interested in collecting these manuscripts. So there were many people who collected these manuscripts, like for example Henry Colebrook or Charles Wish, and also many German scholars who collected these manuscripts, and they would research on them, and they would establish a chronology on them.
Mm-hmm.
And this would be the primary sources. And then also in later times, there are very well-known historians of mathematics like K.S. Shukla, who has, for example, collected manuscripts of the same work from different manuscripts of the same work, and then prepared critical editions of all these works, like for example Aryabhatta's Aryabhatiya, then Bhaskara of Mahabhaskariya and Laghu Bhaskariya, for example, his, and Brahma, and Vateshwara's works he has collected critical editions. So the original Sanskrit text, with commentaries and with translations. So these are the primary references, and I have referred to them often in the book, and I have given original direct quotes, Sanskrit quotes from these works. So these are all established primary references. Then we come to the secondary references. So these are works by modern day historians who like work on the chronology or the bigger historical aspect of the mathematical developments, or maybe they are researching on the influences of different cultures on each other, or how a particular subject developed, like for example astronomy, or the use of instruments in astronomy. So here also I've used a lot of many secondary sources who are well established in the academic world. um, so like Ohashi, one Japanese researcher who has done a great amount of work on Indian astronomy and mathematics. Then from modern times you have Professor K. Ramasubramanian, Professor M. S. Sriram, and so basically what I'm trying to say is that all the secondary references I've used are also like deeply established in the academic world, and all the knowledge that I've presented is well known in the academic world. But like I had mentioned sometime earlier, that this knowledge is restricted to the just to the research circles and academic circles, and it's not so well known to the general public.
Yeah.
So this would be some. Yeah.
I was going to ask, so it's not, so you were saying it's not really accessible, most of this, to the general public, or would you find
No,
things?
I mean to say of course it's accessible in the sense of that you can of course go to the internet and find out many of the references and research articles. That's fine. That's not a problem. But maybe it's kind of too technical.
Mm,
For example, that could be one
yeah.
problem, and maybe you don't know where to find it, right? So for example, I've used refer to the works of some German Indologists, for example, from the 19th century, and it's there on archive.org, but finding them would be a really a tough task, because you first have to find out the journal in which it appeared, and then it's never there straightforward, like that sort of a thing. So you have to look at the journal where it appeared, and then yeah, for example, I use the word, yeah. So that would be some of the things. So
I was just going to ask, what language is most of this, the manuscripts, and is it accessible in respect to, like, is it a modern language, German? How much Sanskrit do you find in these sources?
yes, yes, in the primary references, it's Sanskrit. Some of them are in regional languages like Malayalam. Like Jeshtadeva was a Kerala mathematician who wrote his Yukti Bhasha in Malayalam.
Yeah.
And the secondary references I used like mostly English and a lot of also German references, because I found the work of German Indologists also really valuable in my study, in my researches.
Can I ask you how long it has taken you to research for this book? Because it seems like you have delved into so much different sources of different languages. Your journey into writing this book, it seems quite fascinating and actually inspirational for someone else who has an idea.
I started researching on this topic since 2013, 14 or so. Approximately 2014, I wrote a series of articles on my blog. But then after that, I've been really on and off working in spurts of activity, and yeah, and I also found it really advantageous to have a knowledge of German, because it was really. I'll give you one example. So, in some of the works of Prosody by Pingala, so his Chanda Sutras, so some commentaries have been written by Halayudha and other mathematicians. So these I could not find in the English language, but I could find them in the German language by one Albrecht Weber, written in the 19th century. So this was really useful. And then yeah, yeah, I would say that since about 2014 I've been working on this project.
Excellent. So 10 years of solid research.
Yeah.
Wow. Okay, well, let's move on to this your book and what you kind of cover in the book in respect to some of the topics of mathematics and the Hindu roots for them of them, like you're claiming, or you've found from your sources, such as algebra, trigonometry, the Fibonacci sequence, calculus. Yeah, tell us about some of the topics and how they have the Hindu roots.
So I think I'll begin with one of the most important topics, important results of mathematics. That is the so-called Pythagoras theorem, which is it is really important because the result itself is so fundamental, and secondly, it kind of creates it puts Pythagoras in the light of a pioneer, mathematical pioneer, like the one who started all mathematics in ancient Greek, and in the world for that matter. So this is general perception. So, like for example, with this result, it's not, as I mentioned in the beginning of the talk, it's like I heard this was given in the Silva Sutras. Of course, it's like turns out it's actually true. Surprise. But yeah, so it was. So this is given there in the Silva Sutras, the Pythagoras theorem, where the Silva Sutras are a text of set of texts for constructing Vedic altars, so that they give the geometrical rules. So they are not mathematics texts per se. And this is a pretty well-known fact these days, that they give the so-called Pythagoras theorem in its most general form. What is also really interesting is that the way these constructions are done, they also imply a knowledge of the proof of the Pythagoras theorem. So how this theorem, why this theorem is true. So right. So I have yeah, I can maybe show a slide here, and where you can see, for example, from this figure, that it's in fact, if you just move this triangle from 1 to 1 prime and 2 to 2 prime, you can see that this is actually, this theorem holds to be true. So yeah, but yeah, then right, and then they also contain a lot of other geometrical knowledge, again for the use of creating Vedic altars, for Vedic rituals, altars. And then if you move next, to the next important development, that would be undoubtedly the development of the concept of zero, and the number zero as both as a placeholder and as a number in itself. And so this was a real leap in the history of mathematics, because that revolutionized how you represent numbers. You can represent huge numbers with only a finite set of numbers, 10 symbols. This was impossible in the case of the Roman or Greek notation systems. And not just that, it also made possible um, the arithmetic operations of addition, subtraction, multiplication, division really easy. So these things we learn in school, the number system we learn in school, these operations we learn in school, without really understanding how they work, and these have remained literally unchanged for across centuries. So you can see that it's such a fundamental development. And when you consider these operations of addition, subtraction, division, multiplication, you are automatically led to ideas like negative numbers and fractions. So the idea of subtraction would lead you to the idea of negative numbers, and division would lead to the idea of fractions. So even here, which the rules, all the rules we learn in school for these kind of numbers, they were developed by Hindu mathematicians. And Brahmagupta in the 7th century CE, he explicitly laid down these rules in his Brahma Sutra Siddhanta in a set of verses, where he, how negative numbers are to be combined, the product of two negative numbers, product of one negative and one positive numbers, and division of positive and negative numbers, etc., etc., and how they combine with zero. So equal positive and equal negative, they give you zero. Those those kind of rules. Then also for fractions, he gave all the rules. Then moving on to then the one more subject which we learn in school is, or which really fundamental, is that of algebra. So without algebra, you can it's really impossible to do anything of importance in mathematics. So algebra is commonly attributed to Al-Khwarizmi, but the fact is that it was developed in the Hindu civilization. It was the mathematics of Aryabhatta, Brahmagupta, which made its way to the Arab world, and Al-Khwarizmi wrote his books based on this knowledge, and they got transmitted to Europe. And that's why people in Europe believe that these numbers are the Arabic number system, and algebra is from the Arabic world, from Al-Khwarizmi, which is false, because they were in fact developing the Hindu civilization. So algebra, as we saw, is called Bija Ganita or Avyakta Ganita, and you have yeah. So I spoke about it some point back. So one of the things I would just like to mention here is that today we use the symbol X. So in Hindu algebra, they use the symbol Ya for X. Like the Ya was the short form for Yavat Tavat, or the quantity which is to be found. And they would also use the letters of the the Sanskrit alphabet, or color names, initials of those, the color names. So, and then there were some very advanced ideas like the Kuttaka algorithm or the Chakrawala algorithm in Hindu mathematicians like Bhaskara to Jesh and Jayadeva. So these ideas were developed in Europe centuries later in the 17th century or so. Then, and another very important subject that we learn in school is that of trigonometry. Trigonometry also plays a huge role in all branches of science and engineering. So here also the basic concept of trigonometry, the functions of sine and cosine, which we all learn, they were exclusively Hindu inventions, because when you consider the sine function, it is not the chord but the half chord. The half chord was the Hindu innovation, which becomes the modern sine function, and you have correspondingly you have the cosine function. And the interesting thing is that even the words, more sinus, sine, and cosine, the modern words for these functions, they come from the Sanskrit words for these. So the word for sine in Sanskrit was jya, and the word for cosine was kotijya. So actually, it's the the radius of the circle times r, which is jya, and the radius of the circle times the radius of the circle times sine, which is the jya, and the radius of the circle times cosine, which is the cotijya. So it's just a matter of convention. So apart from that, the modern sign is the same as the jya in Sanskrit, and the cosine is the same as kotijya. So when the Sanskrit works were translated into Arabic, the word for jya was translated as jaib, and jaib in Arabic means gulf or a bay. So and then when these Arabic works were translated into Latin, the word jaib was literally translated into the Latin word for bay, which is sinus, and so the jia becomes a modern sine, and cotijia becomes a cosine. And in trigonometry also, you have all these important relations we learn in school. For example, the sign of the sum of two angles, or things like what happens to the sine and cosine functions in the four quadrants of the circle, how their sign changes, plus, minus, etc. So these were all developed by the Hindu mathematicians. So I give an example here. This is the formula for sine of a plus b, which is sine a cos b plus cos a sine b. So this was given, for example, by Bhaskara too in his Siddhanta Shiromani, in the 12th century. So yeah, here is a Sanskrit verse for this result, and the English translation for that. So then moving on to the next subject of that plays a huge role in subjects like statistics. Computer science is the subject of combinatorics, permutations and combinations. Given n objects, in how many ways can you choose r objects? How many ways can you find permutations of r objects? Things like that. So the formula for the combinations, r combinations from n objects, was given by Mahavira in the 9th century CE from Mysore. So he gives this formula explicitly in the form of this Sanskrit verse. So Ganita Sara Sangraha, in his work, mathematical work, gives this. And the other results for combinatorics are known to other Hindu mathematicians, and Bhaskara too. He summarizes them in his Leelavati. I think in the chapter Ankapasha, if I remember correctly, but there he summarizes all the results for permutations, combinations in this chapter. And then we move on to then another subject which is also really played a huge role in Europe. Only after it got acquainted with this subject from Indian Indologists who translated Sanskrit works, are those of are that of is that of linguistics. So linguistics is the study of language and grammar, and Panini is the most well-known Indian Hindu linguist. He lived in about the 5th century CE, and he wrote his very seminal work, Ashtadhyayi, literally means 8 chapters. So in this he gives rules about 4,000 in number, where you can create any meaningful phrase or sentence from by combining certain words. So this played a huge role in the development of linguistics in the West, and yeah, so and many of his algorithms are like for creating these sentences are recursive and iterative in nature, much in the spirit of how modern computer algorithms are created. And his works had a huge influence on modern day linguists like Leonard Bloomfield, then Noam Chomsky. Their works have deep relations to his works, so I have given references also to these things in my book. For more details, more details can be found there.
Fascinating.
Closely associated with linguistics is the subject of prosody. So linguistics is the study of language. So language, in language, you have, in its artistic form, you have poetry, and poetry is written in certain meters, with accents on certain syllables and certain number of, like, yeah, rhythms and meters. So so in the study of prosody is like, the study of these meters. In Sanskrit this would be called chanda. So you have this Gayatri chanda and Anushtup chanda and so many other chandas. So the most well known of the prosodists is Pingala, also around the 5th century BC, uh, about contemporary to Panini. And his most important work was the Chanda Sutra, where he some of the most well-known aspects of this is the development of the Meru Prastara. The Meru Prastara is today known as the Pascal's triangle, although Pascal lived, centuries uh, Pingala's time. And this is a very fascinating kind of, construction with many interesting mathematical properties, binomial coefficients, and things like that. And his another very yeah, less well known, but really a very important development is the development of the binary number system and the conversion of numbers from the conventional or decimal number system to the binary number system, and vice versa. So he did that for keeping track of the index of poetic meters. And so the exact algorithms of how he did that, etc., are also, I've also described them in my book, with illustrated examples on how it is to be done. Then the work of prosodists is taken forward again by later day prosodists. Jain, especially the Jain prosodists, played a huge role in this. Like yeah, Halayudha, Virahanka. So in their works, sometime in the 9th to the 11th century CE, they they, 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 they they described, what is today known as the Fibonacci sequence. So they wanted to keep track of the different numbers of poetic meters with a given number of time units. So if you, for example, if you have just one time unit, you have just one possibility. If you have two time units, you will have two possibilities, like one long and two short. If you have three time units, you can have three possibilities. So like, one long, one short, and one short, one long, or three short, something like that. And if you keep track of these numbers of combinations, you get 1, 2, 3, 5, 8, and so on. So this would be the so-called Fibonacci sequence, in which each number is obtained by the sum of the previous two numbers. And this is also explicitly written in their works. So all this was, much before Fibonacci was born even. So these numbers are nonetheless called Fibonacci numbers, even though they should be called Virahanka or Hemachandra numbers. So yeah.
Wow.
Then I would finally I will talk about the subject of calculus, which is, as I mentioned, one of the most important subjects in mathematics. It combines literally, everything that we learn in mathematics in school, and talks about things like infinitesimals and limits and those kind of things which we learn in school today. So and we kind of learn in school that this subject was developed in the West by Newton and Leibniz almost single-handedly, and then there was this feud between them and all those things we hear, and it gives us the impression that it magically pops up in Europe out of nowhere, this subject of calculus. And so this is really a very mysterious occurrence. But if you look at the development of this subject in the Hindu civilization, you see that it has a long history, going all the way at least to the times of Aryabhata. So Aryabhata gave us a set of sign tables in terms of second order differences of the sign tables. And this is a really fascinating work. So the fascinating result. So again, I've discussed this in detail in my book, how it incorporates two results of calculus. The so-called second derivative of the sign is proportional to the sign itself. He uses the discrete version of this fact, and that the so-called fundamental theorem of calculus. So it's like this verse has a double meaning, and you can check out my book how the same verse encodes both the results. Then you have, after Aryabhatta, since the Hindu astronomers were interested in getting better and better trigonometric values for their astronomical observations, they created different interpolation formulas. They improved the value of the number pi, and so this was continuous development, and this culminated in the development of the infinite series by Madhava from the 14th century onwards, and his disciples in Kerala. So for example, some of the main results are just tip of the iceberg. This would be the so-called Taylor series for sine and cosine functions. So like for the sine function, sine x is equal to x minus x cubed by 3 factorial plus x5 by 5 factorial, etc., and a corresponding formula for the cosine function. So this was discovered in about the 14th century by Madhava, and Taylor was discovered them in 1715. Then you have the infinite series expansion for the tan inverse function, which is today known as the Gregory series, who discovered them in the 17th century, but Madhava discovered them in the 14th century for the inverse tan function. And then you have the series expansion for pi by 4, which is today known as the Leibniz series. But again, this was done by Madhava in the 14th century. And one more thing I forgot to mention was that in Bhaskara too, in the 12th century, he also gave formula for the area of a sphere, surface area of a sphere, and volume of a sphere. So, and he did not give the entire derivation for that. He stated the result with an indication of why it would work, but the explicit proof is in terms of yeah, all the mathematical technicalities were given by the Kerala mathematicians, starting from the works of the Madhava and so on. So
Fascinating.
yeah,
Really
I think
fascinating.
this.
Uh, do you know what? I'm actually feeling really sad listening to you, because it just feels like more than I was expecting. You've said more than I was expecting in respect to things coming from the Hindu roots, and I just feel why was this suppressed? Why this ignorance? Why do we not know about this? Why does the general world not know about this? That it's come from it's this, these are the roots. Why was a credit not given to the right people? Um, I think what's your thoughts on this?
This is in fact a really it's a deep question, because one has to look at historical developments, religious developments, and political developments throughout the ages.
Mm,
But I think the thing, the root cause from which all these arose was probably the rise of Christianity in Europe, maybe around first second century on CE onwards. So like and it's not, I would not say Christianity, but maybe the rise of the church. I would better phrase it that way. So for the church, it was really important to convert others, because this was a true way to God and reality, and all the other cultures were like non-Christian cultures. They were categorized as heathen or pagan cultures. So this included also the so in Europe at that time, and in Greece around that time, there was this class of philosophers known as the Neoplatonic philosophers. So they were heathens and pagans according to the church, according to the major Christian group that was in power there. So, but the interesting thing is that their philosophy had a lot more in common with the Vedantic philosophy. So, and maybe you may be aware that the philosophy of Socrates, Plato, for example, the ancient Greek philosophers, they had much in common with Hindu philosophy. They also believed in birth, death, and rebirth, the cycle of karma. They did not call it karma, of course, but yeah, the actions of this life have to be paid for in the next life, and so on. If you do bad, yeah, so it was like related to that. And so this Neoplatonic philosophy was very close in spirit to the Vedantic philosophy, and this group was severely persecuted by the church at that time, or the Christians of those times. So and this also included certain mathematicians like Proclus. Proclus was probably a philosopher, but also mathematicians associated with these people like Theon and his daughter Hypatia. And you may be aware that Hypatia was, for example, murdered by a Christian mob. And so these people, they fled to the region of Persia, and there they brought their, their Greek texts, their knowledge with them. So, and then when Persia became Islamized, the rise of science began in the Arab world, centered around Baghdad. So these texts became very useful, and the Arab mathematicians, they translated them into Persian, into Arabic, and of course added their own works to them, their own additions to them. So when but the church, of course, they don't want, they want this knowledge, but they don't want to credit the non-Christian kind of sources for that. So what is done is that uh, um, a source is created for this, which is like the ancient Greeks, Euclid, Archimedes, and everything is ascribed to them because they are dead, they are long gone, and they do not pose any threat to the church. So it's to the advantage of the church to ascribe everything to a far off distant past, which cannot pose any threat to them, instead of to these contemporary heathen or pagan people, non-Christian people. And um, and so this whole thing of ascribing everything to the Greeks comes from the church in that time. So this sort of this ancient Greek history, or this becomes appropriated into a Christian setting. And this is and this ascribing everything to ancient Greece is the pattern which was set by the church, and which was continued later with the rise of colonialism and imperialism. So the colonizing powers, of course, saw it to their benefit that the colonized people should think that everything comes from us, and our forefathers are the ancient Greeks, the inventors of mathematics. So this was then propagated. The interesting thing is that none of the original texts of Euclid or Archimedes exist. They all originally, you all have like the Persian and Arabic texts, which are credited to Euclid and Archimedes by the church at that time. And it is these Persian and Arabic texts which were translated back into Greek and Latin sometime in the 8th century or so by translators in Spain, 8th to 10th century, I would say. They were translated back into Latin and Greek. So all you can say for sure is the state of knowledge till about the 4th or 5th century CE, 4th or 5th century AD. Whereas Euclid, Archimedes, they are supposed to have lived around 300 BC or 300 BCE or 250 BCE. So you'd have no idea what happens in between. So the most you can say is the state of knowledge at about 4th century CE. That's all. So what happens in between? There is no knowledge. So how can you just cannot claim? And this is not. And this fact has been pointed out by well-known historians like David Fowler. He mentions that. He mentions, for example, that in his book, The Mathematics of Plato's Academy, Euclid's Elements, which is believed to have been compiled around 300 BC, gives us an edited and anonymous treatment of some of the mathematics of Euclid's predecessors in a text that has passed through the hands of an unknown number of further scribes and editors before arriving at the versions that we now possess.
Wow.
And certain other scholars also have commented on these incongruities. So yeah, so this would be like ascribing everything to the ancient Greeks
Yeah.
from the church. Then it became the colonial or the imperial agenda, and that has stayed on till today, in today's times. The other thing I would also like to mention is that, like for example, when you talk about the subject of calculus, how the subject of calculus was transmitted from India to Europe, even here the church played a huge role. So here also, blocking out all the non-Christian sources and is to be seen. And one more aspect which the later day colonizers and imperialists did was, when they came in contact with the Hindu civilization, in order to uh, yeah, so you see the same pattern here. So one of the things they did was to create this so-called Aryan race theory. So according to this theory, the Hindus, all the good things that the Hindus have today, be it Sanskrit or arts or literature or mathematics, they are all because of the Aryans who migrated from their ancient homeland to India, and brought their culture with them. And it is these Europeans, the white Europeans, who are the true descendants of the Aryans. And therefore, all that you see here is actually our heritage. You are just a inferior form of the original Aryans, whose true descendants we are. So something like that. And so for example, in the case of mathematics, this is from the historian of mathematics, Roos Ball, from the book 1915 book, A Short Account of the History of Mathematics. So he says, no science or useful art can be definitely traced back to the inhabitants of the Indian peninsula prior to the Aryan invasion. Their descendants, that is the Aryans' descendants, wherever they have kept their blood pure, may still be recognized by their superiority over the races they originally conquered, but they gradually degenerated. For the first 2 or 3 centuries, they retained their intellectual vigor and produced one or two writers of great ability. And he goes on to speak about Aryabhatta and some other mathematicians from the Hindu civilization. So these are, like, some of the things which have stayed on today, in today's historical world, in this historical perspective outlook, which has and of course, one more very important thing is the rise of Islam in the Hindu civilization, with the attacks on Sindh by Muhammad bin Qasim. And so, like, when vast areas of India became Islamized, obviously, you won't have the culture, the atmosphere, the environment for creating knowledge, and that knowledge got destroyed. And then um, yeah, so that has also played its role in the suppression.
Yeah, I'm just feeling actually really, still very sad to just know that, this was all quite intentional, and the egotistical behavior of, certain organizations or people from the past. And I just, I come from a very innocent space, and I just can't even believe that people would have the audacity or the thought to do this, cover up and make it their own. And yeah, plagiarism, that's all I can think of. It's just such a facade. The history, that really, and thank you to people like you who's helping reveal the truth. And yeah, it's just sad. It's just really sad. But the good news is, we are discovering, and I'm hoping people will listen and read and be curious to know and find out the truth for themselves as well, via your book and other sources. So my final question would just be on the the knowledge and the scripts, and and actually this is to help those who are now curious to want to find out more. Where is this sitting? I did recall that there is a lot of stolen manuscripts in Britain, and we touched on it earlier. Is this accessible, like, to the general public? Where is it sitting? How can people find out more?
I honestly don't know the situation about the manuscripts in England, and if what accesses the British government gives to people who may be interested in looking at them. Uh, but in my opinion, I think certainly the Indian government should create pressure on the British government to return the stolen artifacts, the stolen manuscripts. And in fact, this has been also going on. For example, Germany has returned colonial artifacts back to Africa from where it had stolen them. So this is a trend which the Indian government should look into. And more importantly, the Indian government should also look at the manuscripts that are already existing in India. There are countless manuscripts which are just lying in a state of neglect. Research should be funded for analyzing and researching these manuscripts. Sanskrit studies should be funded, and the school curriculum should be changed to, not changed, but it should reflect the true state of history of Indian mathematics, Hindu mathematics. And yeah, and I think I personally believe also that temples should be freed of government control, because temples were traditionally the source of the cultural centers, educational centers in India, and they can play a huge role in bringing awareness back to the people. So of course, I'm not saying that we have to go back to how it was in those times. That is not practical. But freeing government temples from government control would be also a huge step in this direction.
Interesting points. So anything else you want to add? Anything more you have in the pipeline? Are you writing book number 2? Anything that's in the future? Any future projects for you?
Yes, I'm playing thoughts of some ideas are there in my mind. With, for example, in the present book, I worked on the connections between Hindu philosophy, knowledge framework, and mathematical knowledge. And when I see the differences between how Western science is framed, it is framed almost exclusively in terms of the materialistic point of view. Even though from quantum mechanics, you see that that leads to many inconsistencies, but still this persists, the materialistic view, and that leads on to horrifying situations where even consciousness is supposed to come from matter, and ultimately human beings therefore then become simply resources in the for maybe creating wealth or whatever other purposes. So I believe that this narrative, this Indian narrative, is not only important for the Indian people themselves, but for the whole world itself. So I'm probably thinking of writing something along these lines but this is all in a very nascent stage, and have to make some thoughts about this in concretely
Sounds
how I will go
interesting,
about
though.
it.
So I give you all encouragement to, write book number 2 for sure. And we look forward to that. Bhaskar ji, thank you. Thank you. This was really fascinating, eye-opening, and mind-blowing. I think so much to reveal to the world on, the truth of the matters. And this topic and this subject is very relevant to just inspire everyone to know that it's not just mathematics; it's other areas as well, right? But this is a start, and for those who are mathematicians out there who are interested in this subject, for sure. Do obtain a copy of Dr. Bhaskar's book, The Imperishable Seed, How Hindu Mathematics Changed the World. The details of this will be in the description on where you can buy it. And we thank you for watching. And Bhaskarji, once again, thank you so, so much.
Namaste. We hope you enjoyed this Chitti Media content. Please remember to subscribe to us and switch on the notifications for this channel. For our other social media links, more content, and to support our work, please visit citti.net. Dhanyavad. Namaskar.